class. Today we're looking at Chapter 9, Lesson 2, Experimental Probability. So manufacturers collect data on the quality of their products. They use experimental probability to determine how many defective items they can expect to produce. Probability based on experimental data or observation is called experimental probability. Okay, so please be sure to write that down. Experimental probability. Probability based on experimental data or observation. Ooh, I didn't spell that right. Let's try that again. Observation. Okay, so experimental probability takes an event, so the number of times of it occurs divided by the total number of trials. So let's look here. You're attempting 16 free throws in a basketball game. Your results are shown. What is the experimental probability of making a free throw? So the 0 means misses, 1 means you made it. So you made it 1, 2, 3, 4, 5, 6, 7, 8 times. So 8 throws were made and you had 16 attempts. You could count all the numbers. And so then let's simplify that. 8 over 16, 8 goes into both those numbers. If we divide the top by 8, and divide the bottom by 8, we get 1/2. The experimental probability of making a free throw is 1/2, 1 out of 2. Okay, so doing an experiment to see about how much it should work. So think about this one on your own. Press pause, see if you can figure it out. Come back to me when you're done. In 60 coin toss, 25 are tails. Find the experimental probability of getting tails. So the experimental probability you should have got was 5/12. And see, this is different than what we were working on yesterday. Because if you would ask what the probability of getting tails is, it's 1 out of 2. There's 2 sides and 1 side. So this is actually doing the experiments. And so that's why it's called the experimental probability. You're actually trying it. The chances of getting it is still 1 out of 2, but the probability based on this experiment is 5 out of 12. Okay, and this is not multiple choice. A bicycle company checks a random sample of bikes. The results are shown. If the trend continues, which is the best prediction of the amount of defective bikes in a batch of 1,300? So here's our results. So 12 out of the 400 bikes checked were defective. Okay, so we could reduce that down. We could divide the top by 4 and the bottom by 4. And gives us 3 out of 100 bikes are defective. So now we have to tie that into an equation with the batch of 1,300. So if we then do 3 over 100, is going to equal how many defective bikes out of the 1,300. So we can cross multiply. Get rid of the 100. So x is going to equal 39. So there's going to be 39 defective bikes based on this experimental probability. Try this one on your own. Predict the number of defective bikes in a batch of 3,500. Press pause, come back to me when you're done. So you should have got 105 bikes, right? You used the same equation from the original information and then plugged in how many defective if there were 3,500 produced. Okay, so your homework tonight is page 315 and 316, numbers 3 through 21 odd, and skip number 15. Happy homeworking!